So again, we're talking about parallel lines never intersecting. Parallel lines that, or lines that are parallel, always have equal slopes. The reverse of that is lines that have equal slopes are parallel. So again, if you're looking at the equations and you see equal slopes, you know those would have to be parallel. And then two different undefined slopes are parallel also. All right, so perpendicular where they're intersecting and they intersect at a right angle. So you can see in our graph up there, these two lines are intersecting and there is a right angle there. You might remember from previous courses, we said they had opposite reciprocal slopes. And so remember, opposite reciprocal means if I had like 3/4, the opposite reciprocal is -4/3. Okay, so you change the sign, so one always has to be positive, one has to be negative, and you flip the fraction. What happens when you multiply 3/4 times 4/3, or -4/3? It equals -1. Okay, because I get -12 over +12, -1. So if I had a slope of 2, what's the opposite reciprocal of 2? -1/2. And again, if I multiply 2 times -1/2, I get -1. So another way of saying opposite reciprocal slopes that you may not have seen before or heard it this way is the product of their slopes equals -1. So if you see lines that are perpendicular, their product of their slopes are always -1. And then if the product of the slopes of two lines equals -1, then they're perpendicular. So if you look at two equations and you notice their slopes are opposite reciprocals, or if you notice their slopes would multiply to -1, they'd have to be perpendicular. And then if you have a horizontal line with a slope of 0 and a vertical line with an undefined, those will also become perpendicular also. Okay, so once you have all that, that's what we're going to build off of for next time. All right, so we're going to work with that whole idea of parallel and perpendicular today. So here it says determine if the following sets of equations are parallel, perpendicular, or neither. So just take a moment and write all 6 of those equations, but pair them up as they are here, because we're trying to see are these first 2 parallel, perpendicular, neither, and then the next 2 and so forth. All right, so for us to determine if these equations are parallel, perpendicular, or neither, we need to find the slopes. All right, so in our first set here, the bottom equation is pretty easy to find the slope because it's in slope-intercept form. So here the slope is 3/4. For the top equation, though, we're going to have to get it into slope-intercept form. So remember, if it's in standard form, to get it into slope-intercept form, we would need to get the y by itself. So we'd add 9x. And then we would divide by 12. And remember, we always want to reduce when we can. So 9/12 can be reduced by 3/3. So 3 goes into 9 3 times, 3 goes into 12 4 times, and then 24/12 is 2. So here we have a slope of 3/4 also. So therefore, this first set would be parallel. For the second set, again, neither of those, the y is totally by itself. So again, we would have to get the y by itself. So we subtract 10x from both sides. And then divide everything by 8. So negative 10 over 8 would reduce by 2. We divide everything by 2. 10 divided by 2 is negative 5. 8 divided by 2 is 4. And 16 divided by 8 is 2. So that top one has a slope of negative 5/4. The second one, all we have to do to get the y by itself is divide everything by 5. So that would give us y equals 4/5 x minus 3. So that has a slope of 4/5. So that one would be perpendicular. One slope's 4/5, the other is negative 5/4. So if we flip the fractions and change the signs, those are opposite reciprocals. Or if we multiply those two together, it would give us a product of negative 1. So these are perpendicular. All right, go ahead and try that third one. Take a moment and do that. So for our top one, all we need to do is subtract x. So that would give us y equals negative x plus 7, which is a slope of negative 1. And then for our bottom one, I could add y and subtract 9. So we'd have y equals x minus 9. Slope is 1. So if I have a slope of 1 and a slope of negative 1, if I multiply negative 1 times 1, what do I get? Negative 1. So the product is negative 1, or they are opposite reciprocals, because remember there's really a 1 underneath any 1, or any number. So this would be perpendicular also. All right, so next part, you don't have to write the entire thing down, but it says write an equation of a line through the point negative 2, 5 and parallel to the line whose equation is y equals 3x plus 1. So if I were you taking notes, I would just say equation of the line, write the point, write parallel, and you can write the equation. So what's underlined there is probably what I would write down. Equation of line going through negative, or equation of line, negative 2, 5, parallel, y equals 3x plus 1. So since it is parallel, we need to make sure it has the same slope as the equation that's given to us. So our original equation is 3, so that means the parallel slope also has to be 3. So I just wrote m, which is slope, and then the double L means parallel. And then our point that's given to us is negative 2, 5. So that's going to be our x1 and y1. So now it's essentially what we've been doing. Okay, we just need to make sure our slope's 3 going through negative 2 and 5. So I'm going to use point slope form to start. The directions do say to write it in point slope form first and then slope intercept form after. So y minus y1 equals m times x minus x1. Remember, you will need to know point slope form. I'm not going to give that to you. So we can plug that in. So it'll be y minus 5 equals 3 times x minus a negative 2, which would be plus 2. So we would distribute. So that is our first answer. That is the point slope form answer. Remember, point slope, we can leave it like that. To get into the slope intercept form answer, then we would want to distribute the 3. And also then we have to add the 5 over. So add 5. And so the slope intercept form would be 3x, y equals 3x plus 11. All right, so that's our parallel example. Then the perpendicular example. So you can say perpendicular to this equation, and then our point is -2, -6. So this equation is in standard form to start, so we're going to need to get it into slope-intercept form so that we can pull out the slope. So I want to get the y by itself, so I'm going to subtract x and add 12 to both sides. That way, I'm trying to get my y by itself. So I'd get 3y equals -x plus 12. And then we want the y totally by itself, so we're dividing everything by 3. So y equals -1/3 x. 12 divided by 3 is 4. So this has a slope of -1/3, but we want it to be perpendicular, so we need the opposite reciprocal. So we have to flip it and change the sign. So our perpendicular slope, so I'm going to write m with an upside down t, that means perpendicular, would be +3. And then we have the point -2, -6 that we're using. So that would be our x1 and y1. So I'm going to write this in point slope form to start. Even though the question does say write in the general form or the standard form, we're still going to need to get in the point slope form first to make us able to do that. So there's our point slope form. And we plug in -6 for x, so it'll be +6. The m is 3. And then minus the -2 will be x plus 2. So that's the point slope form, even though we didn't really need it in point slope form, or at least the final answer. That's going to be a part along the way. Now, remember, in standard form, it means the x and y are on the same side. So I'm still going to distribute and get 3x plus 6. And then I'm just going to get all my x's and y's on one side and my constants on the other. So when I go get my constants on the one side, I actually get those constants all cancel out. So right now I'm at y equals 3x plus 6. So this is actually the slope-intercept form. And for us to get it into standard form, again, our x's and y's need to be on the same side, and our x needs to be positive. So our 3x is already positive on this side, so I'm going to subtract y. So we have 3x minus y, and on the other side of the equal sign, we have nothing. Y minus y is 0. So it would just be 3x minus y equals 0. That's your standard form. And so technically this is the point slope, this is the slope intercept, and this is the standard. Now all you really needed, the directions just said to write the standard form, but along the way we just happened to reach each form because of needing to get in the standard. All right, so you're going to have some time right now to work on the homework, which is 279, numbers 5 to 11 odd, and then 19 to 23 odd. So you're probably going to need to get your book out because you can't fit it all in.